Hey guys, it's Kyle Bennett with hardoscp.com, and again we've got our Asus Strix X399E gaming motherboard out here, and we showed you yesterday exactly how we installed the Threadripper CPU down into the socket, and today I'm going to go through how we have learned to apply our TIMs for Threadripper here. Applying your thermal interface material to Threadripper might vary greatly from exactly how you would do it with any other CPU because of the huge surface area we have here. So the things we're going to use are, I'm going to use a lint-free cloth. We use these little finger condoms, which are called finger cots. A little bit of canned air. Isopropyl alcohol. This is isopropyl alcohol is 99.9%. Some people say you don't need it, and they would be exactly correct on that because you do not. 99% is pure anhydrous. It means there is no water in this for all intents and purposes. And I like to use it because it simply burns off faster, evaporates faster when you use it. You can use lower grades of isopropyl, that's fine. Just keep in mind it is conductive, so I would not use it on anything that has a live current to it. This is MG Chemical Super Thermal Grease 2. We use it a lot on the test bench when we're just doing test fittings and different kind of things. I'm going to use this today to show you exactly the process because it's much quicker than the ProLimitech PK1 that we use in general for all of our testing. It has a much higher thermal conductivity rating than something like this, probably about 5 to 6 times higher. We're going to use our little die template, and what we're going to test fit with today is going to be the Heat Killer 4, which we're getting on the test bench. We'll use that since we don't have it plumbed in yet. It'll be easy on, easy off, and hopefully we'll get that shown. We also will use a spatula, which comes with a lot of these thermal interface materials nowadays. And with that said, let's get right to it. So here is the surface of our Ryzen Threadripper 1950X. I'm simply going to take a paper towel, and I'm going to clean this off using isopropyl alcohol. Now, people say don't ever use paper towel on this, and they would be correct. And I'm going to go over this as if you were going to do this in a permanent install. Paper towels have a tendency to leave a lint behind, and you see how much old TIM I got off there with just the first cleaning. So I'm going to flip this over again. I'm going to get me a little more clean alcohol and a clean surface. Let's see how much we got that time. So you can still see how much TIM came off. So I'm going to do it again. And I'm going to do this until we basically see we're not getting any of the old TIM off here. Getting a lot closer. Still, you can see how much TIM material's on there. This stuff runs really, really deep. Obviously, if you've not installed yours before, yours would not be this much trouble. And you can also see how quickly that alcohol burns off there. Okay, so I'm good with that. Still could go a little bit longer. You can see how the alcohol's flashing off. Once the alcohol's flashed off, I'm coming back with a clean, lint-free cloth. I'm going to clean the surface of that really good. Obviously, this is easier to do if you do it outside of the case. And still, you can see we're still got some of that old TIM material in there, even though it looks perfectly clean. You can keep doing that until you get absolute zero residue back off. I personally am not, because I'm not that concerned with it for this. But for a good install, I would suggest you get it as clean as possible. For purposes of this, I'm going to lay this down. So if you remember correctly, this shows us where our active dies are. So we have active die right there. And we have an active die right here. So I'm going to get a little TIM out of our white TIM. Like I said, I'm going to use this because it flows much easier. And this is basically kind of how we do it here. Kind of dot some around, and you'll see exactly why. This is nothing like you would probably do it on any other kind. Now, if you have it coming out of a syringe, it's easy to dot down. I'm pulling it out of the tub here. So now we got our finger caught on. I'm gonna come back and we're gonna move in circular motions. And I'm gonna start applying that all over the face of the Threadripper. Now keep in mind, I know a lot of people are gonna say that's not how you do it, but keep in mind, I've probably mounted and tested over 100 different Threadripper installs at this point. I'm going to come back and I'm going to wipe the excess off of my finger cut. Obviously you'd want to use a clean lint-free towel for that, so let's wipe the rest of it off. Let's get all the excess off in the paper towel. We'll come back over here, wipe it off with the lint-free cloth, make sure we have nothing on there, and now we're going to come back and spread all this out. We're trying to get a layer down across the whole entire surface of this heat spreader that we can. Okay. We'll come back with this spatula. Removing all my excess. Some people use credit cards for this. I like kind of using the spatula, makes kind of a paintbrush kind of thing. Angle doesn't matter. Okay, I was wondering if our dots would show up through there, which they did not. So now we've got, if you remember where our tabs are, or where our cores are, we'll come back and make a little mark right there. So that's where we are, and that's where we are. That's where our 2 active dies are down on that package. All right. So now what I'm gonna come back and do is this is what we found to work best. Like I said, we've tried a bunch of different mounting methods. So I'm going to come back and I'm going to place a small dot of TIM right on top of that die. So we've got the mounting hardware in our block. We're going to get it down onto here. Oops. We're going to float it down easy. Okay, now if you remember, we had diagonal this way where our active cores were. Those are going to be the 2 fastening points that we focus on first. Just wanted to grab a single thread there. It's already cranking up. There we go, get a single thread there. I'm going to turn, I'm going to turn, turn, turn. So my initial pressure that I wanted to put down was across, diagonal across the active dies, okay? Remember, our active dies are here. This is where I wanted our first, was where I wanted our initial pressure down on the block. And this is actually important. Not there. All right, so our fasteners have bottomed out there. There's no reason to crank on those or use any kind of real force on them because you're just going to tear things up. Okay, now keep in mind that our seat here is going to be without any heat to flow the TIM material across the face of the Threadripper. So let's come back and look and see exactly what we got out of this. Okay. Now getting these off, once you've seated these down, it can be exceedingly difficult. We'll see how this one goes. If we've seated down there real good, we'll have a really good vacuum. And I would suggest we do have a really good vacuum. And I bet we can actually pick this motherboard up by it. Let's see what happens. Look at that. So that's picking up the whole motherboard quite easily. And we haven't even had any heat applied. Okay, moment of truth. Let's see what we're dealing with here. All right, so look at our footprint here. As you notice, when we put it down, so we flowed over here first because we kicked up to that corner over here instead of holding it down. Should have held it down by hand. We didn't flow as far this way as we wanted to, and we didn't flow as far this corner as we wanted to. So there is the outline of our footprint. All right, and our die center is right here, and our die center was right here. All right, so we had very good flow down over those dies. Let's take a look. So we'll say there's the end of our die there. And we'll say there's the end of our die there. All right, so we did have flow down over the entire die. Let's say this. All right, and this is most important. All right, and obviously that's not a good way to draw that, but so we had flow down to there, and we had flow footprint over here. Now, if you're mounting these Threadrippers, I'm explaining to you, you should do a couple of test fits and go back and see exactly if the technique that you're using works for you. Okay, I would have loved to have seen us get down onto the interface over here, or get down onto the heat spreader over here, and you know, but this is really what you're working for at this point, are these two areas, and to make sure that those two active dies are covered. Now, if you get a better mate when it's down a little bit flatter than this, I would suggest that you can get maybe a degree or two better off your low die temperatures. But as long as you have that die covered and that die covered, you're going to be doing very, very well. All right. Now, given that if we'd have put this under heat and let it flow for a few hours, it's very likely we might have come down and gotten a better footprint than that. So what I'm gonna do is I'm gonna clean this all up, and I'm gonna go back and do it again. I'm gonna make sure we hold the die flat this time going on, and or hold the heat sink or the water block flat going on this time, and see if we can get a better mate. Die footprint there. So that shows you relatively where your active dies would have been. We made it out to the edges of both of them again. I would suggest this time we did not use quite a bit enough of TIM. And this is why it comes into being really, really important that you go back and look at these things repeatedly and to figure out what you need. This is the first time I've used this mounting system on the heat killer block. So we've got to dial in. That's one of the reasons I'm filming this. So we're trying to dial in and figure out exactly how we need to mount this TIM or mount this block in order for us to get the best TIM footprint that we can. And this time I am going to use the PK1 that we're going to use for the actual testing. I'm going to let this sit on here for about 10 or 15 minutes and let it flow a little bit. So let's see how it came out. Not sure I'm going to be able to pop this one off. I mean, it's on there. And this more viscous TIM is not as forgiving. I can't get it off. So that's obviously a good sign. I'm not going to suggest that you do what I'm about to do at home, because number one, it's going to scratch your block up a little bit, and number two, you have a chance of damaging your motherboard. But I'm actually going to put this screwdriver in between here so I can get a little leverage. Now at home, you simply twisted that block to get some air under it while pulling. You could have got it up, but I wanted to bring it up directly so we could see the footprint that we got. So here is where our TIM pattern was. So that is where our footprint was. We could have probably used, like I said, I was light in this corner very much. And obviously I was light in this corner to spread. But again, where we want to make sure our contact is right here. And right here. Now this more viscous TIM would have certainly more viscous TIM would have flown a little bit more better, or flown a little bit better, and given us better contact after we'd had it under heat for a while. I've literally mounted hundreds of these, and we've talked to some of the block makers too of what they found out. XSPC, when we first started this and really getting into this, XSPC liked putting, doing the full spread across the heat spreader and then putting one dot in the middle. I've had better results of putting the dot out here over this die and a dot out here over this die. So we're gonna get back to testing, but if you're doing this at home, I suggest you make a couple of test runs and see exactly if it's working, how it's working better for you. If you can do this outside of the case, it makes it much easier. And I hope this has done a little bit better in helping you understand exactly what you need in terms of footprint and TIM material down on your Threadripper. This is Kyle Bennett with Hard OCP.